The second major type of reasoning is what we call deductive reasoning. Remember, inductive reasoning, we use many individual details of the same type to draw general conclusions. Deductive reasoning, in a sense, works backwards. What it does is it actually takes a specific detail and it combines it with a general concept that we may have derived from inductive reasoning or perhaps from our metaphysics, and it puts the two together to draw a specific conclusion that is a new specific fact that we didn't know before. Deductive reasoning can be extremely powerful, and let me demonstrate this to you. Here's an image of a dinosaur tooth. You can pause the video and look at this tooth carefully. Make all the observations of details that you can, and tell me what you can about the dinosaur that this tooth came from. So pause the video just for a second and think about it. Now, many of you will probably have thought about the idea that, well, if you look at this tooth, it's got a rounded top here, it's not sharp, and so you may be able to conclude from that. You have a reason to believe that this dinosaur was a herbivore. It ate plants. If it were a carnivore, its tooth would probably be sharp. Here's what I can tell you as somebody who has learned about paleontology and dinosaurs. Here's what I can tell you from this tooth. The dinosaur that this tooth came from had these teeth possibly all around its jaw, but definitely in the front of the jaw. It had a small skull. It had a long neck. It was one of the long-necked dinosaurs that you know from Land Before Time. It had a long tail. The pubic bone, which is one of the three bones that make up a hip girdle, was directed towards the front rather than the back. It walked on 4 legs. It was quadrupedal, and they were massive tree trunk-like legs, all approximately the same size. And at the end of each leg, there were 5 broad toes on each foot, no claws. All of that can be deduced using logical reasoning, using deductive reasoning from this tooth. How do you do that? Well, it has to do with an idea that I've emphasized to you multiple times, the distinction between ideas and details. Remember, ideas are broad concepts that cover a lot of the world, whereas details are very, very specific and cover only a tiny little part of the world. Well, what's important is that ideas and concepts actually tie many of these details or facts together. Now, using empiricism, we can discover certain facts that will allow us to rationally connect whatever we're studying to some particular concept or idea. And once we've connected it to this concept or idea, then all the other details that apply to that concept or idea also become known to us, even though we've never observed them. So in fact, deductive reasoning is another way to extend the senses. Let me try to illustrate what I mean by this. So if you study paleontology, if you study dinosaurs, then what you will learn are general ideas about dinosaurs. So one idea about dinosaurs, and it's an idea because it's broad, it covers all dinosaurs, is that dinosaurs can be classified into 2 different orders based on their hip structure. Now, this is an idea too because there are many questions that arise from this, like how do they do this? What are the differences in hip structure that they're looking at? So here are some of the details. One order of dinosaurs are what are called the Saurischian dinosaurs. Saurischian literally means lizard-hipped. And in this case, like modern-day lizards, the pubic bone, which is one of, as I said, one of the 3 bones that makes up the hip structure of any animal, along with the ilium and the ischium, the pubis actually points towards the front while the ischium points backwards. So there is this split here. On the other hand, The ornithischian or bird-hipped dinosaurs, like modern day birds, have the ischium and the pubis in the same direction. The pubis is pointing backwards. There may be an extension that points forward, but the major part of the pubis points backwards, parallel with the ischium. Another basic idea about dinosaur classification is that in addition to this basic distinction of hip structure, these two orders of dinosaurs shared other common characteristics. The details of that are this. The saurischians, the lizard-hipped dinosaurs, all had simple peg-like teeth, and these teeth were in front or perhaps all around their jaws, but always in the front. The ornithischians, on the other hand, they were all quadrupedal. They all walked on four legs, but the front limbs tended to be somewhat smaller or perhaps very much smaller than the hind limbs. They were all herbivorous, and because they ate only plants, their teeth were modified by being broadened or flattened out for chewing plant material. These ornithischians only had teeth in the back part of their jaws. The front of the jaw was often modified into a beak-like structure or a bill-like structure. A third basic idea about dinosaur classification is that the saurischian dinosaurs are further classified into what we call suborders based on their diet. What are the details of these two suborders? Well, one of them, one suborder is called the theropods. The theropods were all carnivorous, which means they had sharp, possibly serrated teeth. They were peg-like, but they were sharp. And these theropods walked on two legs. They were bipedal. They had the short front little limbs, if you think of a T-Rex, and their limbs, both their hands and their feet, ended with claws rather than toes. So all carnivorous dinosaurs were theropods. The other suborder is called the sauropods, or there's another smaller group within the sauropodomorphs, and they had certain characteristics. They were all herbivorous, and therefore their peg-like teeth were dull rather than sharp. They all had the small heads, long necks, long tails, and the four massive legs that they walked on, all of them with 5 toes at the end of their feet. And so looking at this dinosaur tooth, by simply matching its general shape to the concepts of saurischian dinosaur and sauropod dinosaur, you now can tell an awful lot about the owner of this tooth. So here were the two details that we noted, that there were simple peg-like, it's a simple peg-like tooth, and it's dull. The simple peg-like shape tells us that we can connect this dinosaur to the concept of the saurischian or lizard-hipped dinosaurs. And once we've done that, if it's a saurischian, then we know the hip bone, even though we can't observe it because we only have a tooth, the hip bone must have been directed forwards, not parallel, but opposite to the ischium. The fact that the tooth is dull tells us that this dinosaur must have been herbivorous. And now we know the herbivorous saurischians were the sauropods. So we can now link that one fact of a dull tooth in a dull peg-like tooth to the suborder of sauropod. And if this dinosaur was a sauropod, that means it had to have a small head, it had to have a long neck, and it had to have a long tail. It had to be quadrupedal with massive legs with 5 toes each. And in fact, this is the dinosaur that it came from, a Diplodocus. And you can see here all the details we talked about. It's quadrupedal, 4 legs, 4 massive legs, the long neck, the long tail, the small head at the end of the long neck. If you look at the hip structure, there is the ischium pointing backwards, there is the pubis pointing forwards. What about the head? If we get a picture of the head, remember the saurischians had their teeth in the front of their jaws, perhaps all around, but in this case only in front. Simple peg-like teeth that were flattened because this was a herbivore. And if you look at the end of the feet, the 5 toes rather than claws.